Welcome to David Alexander Maths Tuition. This is chapter 9e on the quotient rule. Okay, so a lot of people are taught using du, dv, all these sort of weird letters which some people can find quite confusing. The way I've always done it is I just write it as 7x and the x plus 3, differentiate them both, so 7x goes to 7, x plus 3 goes to 1, and now I'm combining bottom left with top right, so that is 7 lots of x plus 3, so 7x plus 21, subtract top left bottom right minus 7x, and that's all over the top right squared, x plus 3 squared. So we can say therefore that dy by dx is just the 21 over x plus 3 all squared. Let's look at another example. So 8x differentiates to 8, 2x minus 7 differentiates to 2, so it's 8 lots of 2x minus 7, so that is 16x minus 56, take away 16x, and that's all over 2x minus 7 all squared. In other words, dy by dx is negative 56 over 2x minus 7 squared. Okay, so here's another example. So we've got 4x squared, we have a 2x plus 1 squared. Let's differentiate them both. So that's going to be an 8x, and that's going to be 4 lots of 2x plus 1. Bottom left times top right, so that is going to be 8x lots of 2x plus 1 squared. Take away 16x squared, lots of 2x plus 1, all over the top one squared, and 2x plus 1 squared becomes 2x plus 1 to the power of 4. Now I can divide each part by a 2x plus 1, so take out a 2x plus 1 there, reduce the 2 to a 1 and reduce the 4 to a 3. And we can also expand the top, so that's going to be 16x squared plus 8x minus 16x squared all over 2x plus 1 cubed. So therefore our derivative is, the 16x squareds cancel out, that's simply 8x over 2x plus 1 cubed. Okay, here's another example, but it's got some slightly annoying powers. So 3x cubed differentiates to 9x squared. The 5x plus 1 to the power of 1 half will differentiate to 5 over 2 lots of 5x plus 1 to the negative half. So let's just do our usual. So that is 9x squared lots of 5x plus 1 to the power of 1 half. Take away, and that's going to be 15 over 2 x cubed 5x plus 1 to the power of minus 1 half, and that is going to be all over the top right squared, and 5x plus 1 to the power of a half squared is 5x plus 1. Now we can see we've got a 5x plus 1 in each part, so to a lot of people it's not obvious how we can simplify this. We can always divide through by the lowest power. So here the lowest power is this negative half, so I'm going to divide everything through by minus 1 half, or 5x plus 1 to the minus 1 half, so that one will vanish completely. Now we need to be careful here. So we are dividing by something, I'll just say x to the power of minus 1 half. So if we had x to the power of a positive half divided by x to the power of a negative 1 half, well, when we're dividing we subtract the power, so a half take away minus a half is a half plus a half, which is 1, so that becomes to the power of 1, and this would therefore become to the power of 3 over 2. Now we can expand out the brackets and simplify a little bit. It's going to be 45x cubed plus 9x squared, take away 15 over 2x cubed, all over the 5x plus 1 to the power of 3 over 2, and 45 take away 15 over 2 is 75 over 2, so our derivative is 75 over 2x cubed plus 9x squared all over 5x plus 1 to the power of 3 over 2. Okay, here's what looks like some slightly trickier ones, but we'll do it in exactly the same way. So we've got e to the 3x, we've got a sine x, so let's differentiate them both. So that is 3e to the 3x, and that is a cos x. So bottom left, top right, so that's going to be 3e to the 3x multiplied by sine x, subtract e to the 3x cos x all over sine x squared, which can be written as sine squared x. Can we do any simplifying? Well, we could take out a sine from everything. I mean, I'd be tempted just to leave it as it is. If I divide through by sine, then I would have 3e to the 3x. Take away e to the 3x. Now, cos x divided by a sine x is a cot x. And that would be over just the 1 sine x. So if you think it looks better, this one on the right than the one on the left, then that's great, but it probably doesn't matter which one we use. Whichever, unless the exam board insists on it being written in a certain way, then both of these are equally valid. Right, let's have a look at the second example. So here we've got cos squared x and ln x. So we can differentiate both. The derivative of ln x is 1 over x, and the derivative of cos squared x, remember that that is the cos of x all squared. So power comes down to the front, reduce the power by 1, so cos x to the power of 1, multiplied by the derivative of cos x, which is negative sine x. There we go. So this one's probably going to be quite ugly. Let's combine it as we normally do. So minus 2 ln x cos x sine x, subtract cos squared x over x, all over the ln of x squared. There we go. So that's probably best left as it is, really. Again, yeah, not a particularly attractive looking equation, that one. Okay, and here are a few more pretty disgusting examples. So here we've got e to the 3x plus e to the minus 2x, and we've got ln x. So let's differentiate both. 1 over x, 3e to the 3x minus 2e to the negative 2x. So combining bottom left and top right was going to give me 3e to the 3x minus 2e to the minus 2x multiplied by ln x. Take away e to the 3x plus e to the minus 2x all over x, and that is all going to be divided by the top right squared, so it's another ln x all squared. Okay, so actually, although they look horrible, they're actually easier because there's not much simplifying that can be done. Right, let's have a go at the next one. So ln of 3x squared, what is the derivative of that? That is going to be 6x over 3x squared, and sine squared x, remember that is the sine of x squared, so power comes down to the front, reduce the power by 1, and the derivative of sine x is cos x, so I'll probably write that as 2 sine x cos x. Okay, so top left, bottom right, that's going to be 6x sine squared x over 3x squared, take away 2 sine x cos x ln of 3x squared. Just realise the 6x over 3x squared can obviously be simplified. Just divide through by 3, so that's going to be 2, that's going to be 1, and we can also take out an x there as well. So that's now 2 sine squared x, and of course this is going to be all over sine squared x squared, and remember that the sine squared x is sine of x squared, so we can write that as sine of x to the power of 4 or sine to the power of 4x. Okay, and we can see that we've got a sine x in all of them, so if I can take out 1 sine x here, I can take out 1 here, and I can take out 1 here as well. So the final answer will be 2 sine x minus 2 cos x ln 3x squared, and that is going to be all over sine cubed x. Okay, so yeah, two particularly unappealing looking equations there, but they are both the derivatives of what we were presented with to begin with. Find the value of dy by dx at the point 2, a 12th on the curve with equation y equals 3x squared over 5x plus 2 squared. So as we've got a fraction, we're going to use the quotient rule. So 3x squared, 5x plus 2 all squared. Let's take the derivatives of both. So that's 6x, and that is 10 5x plus 2. So bottom left with top right there. So that is 6x, 5x plus 2 all squared. Take away 30x squared, 5x plus 2, and that is all over 5x plus 2 squared, so 5x plus 2 to the power of 4. So this is my dy by dx, and I can just substitute in 2. The y coordinate's not really particularly useful here, but rather than substitute it in multiple places, maybe I can simplify by dividing through by a 5x plus 2. That's simplified it a little bit. And if I expand the top, my dy by dx will be 30x squared plus 12x, take away 30x squared, which is nice, that's just a 12x, all over 5x plus 2 cubed. Okay, so let's write this a bit more neatly. Dy by dx is 12x over 5x plus 2 cubed. So at the point when x is 2, that's going to be dy by dx will be 24 over 5 times by 2, which is 10. 10 plus 2 is 12, and 12 cubed is, I know what 12 squared is, but not 12 cubed, so 1728, and 24 over 1728 is 1 over 72. So dy by dx, or the gradient of the curve at this particular point, is 1 over 72. Okay, so here we need to find the stationary points. Now the key thing with stationary points is that the derivative equals 0. So using the quotient rule, let's work out the derivative of 3x cubed over ln x. So 3x cubed goes to 9x squared and ln x goes to 1 over x. So dy by dx is going to be 9x squared times ln x. Take away 3x cubed over 1 over x, which is going to be 3x squared, and that is going to be over ln of x squared, and all of that is going to equal 0. Now when a fraction equals 0, the denominator can be ignored, so we can simply say that 9x squared ln x minus 3x squared equals 0. Now we're going to factorise out the 3x squared, so that's going to be 3x squared, 3 ln x, take away 1 equals 0, so therefore 3x squared equals 0, and 3 ln x minus 1 equals 0, or 3 ln x equals 1. So let's look at the 3x squared equals 0, so therefore x squared equals 0, x equals 0. And if 3 ln x is 1, then ln of x is 1/3, and x is e to the power of 1/3. So there are my x solutions, and now I just need to work out the corresponding y solutions by just putting them back into the formula. Okay, here's an example where we need to work out the equation of a tangent. So that words like tangent, normal, stationary points, these are things that should set off an alarm bell for differentiation. So let's differentiate the function. We've got ln x, and we have 4x squared. The derivative of ln x is 1 over x. The derivative of 4x squared is 8x. Bottom left, top right, multiplied together becomes 4x. Subtract top left, bottom right, 8x ln x over the top right all squared. 4x squared squared is not 4x to the 4, it's 16x to the 4. We can take an x out of each part, so that 4 will become a 3, and we can actually divide through by 4 as well. So our derivative is going to be 1 minus 2 ln x over 4x cubed. Now when x equals e, then our dy by dx is 1 minus 2 ln e over 4e cubed, and 2 times the ln of e is just 2, so that is minus 1 over 4e cubed. Okay, so let's use the standard formula, which is y, take away the y value, which is 1 over 4e squared, equals our gradient, which is minus 1 over 4e cubed, lots of x, minus the x value, which is e. So y equals minus x over 4e cubed plus e over 4e cubed plus 1 over 4e squared. So therefore y equals minus x over 4e cubed. This fraction here can be simplified to 1 over 4e squared, and 1 over 4e squared plus another 1 over 4e squared is 2 over 4e squared, which is 1 over 2e squared, and that is the same as, so here's my negative x minus x. Actually, it's probably easier if I just take the denominator of e to the 3 and make that e to the minus 3. So that's minus x e to the minus 3 over 4, which is minus 1/4 times by x e to the minus 3. And this is plus 1/2 e to the negative 2. And that is what we're aiming for. So yeah, so some fiddly bits at the end there by moving denominators sort of upstairs and dealing with fractions and whatnot, but there we go. So y is minus 1/4 x e to the minus 3rd plus 1/2 e to the negative 2 as requested. Okay, here's an example where we need to work out the equation of a tangent. So that words like tangent, normal, stationary points, these are things that should set off an alarm bell for differentiation. So let's differentiate the function. We've got ln x and we have 4x squared. The derivative of ln x is 1 over x. The derivative of 4x squared is 8x. Bottom left, top right, multiplied together becomes 4x. Subtract top left, bottom right, 8x ln x over the top right all squared. 4x squared is not 4x to the 4, it's 16x to the 4. We can take an x out of each part, so that 4 will become a 3. And we can actually divide through by 4 as well. So our derivative is going to be 1 minus 2 ln x over 4x cubed. Now, when x equals e, then our dy by dx is 1 minus 2 ln e over 4e cubed, and 2 times the ln of e is just 2, so that is minus 1 over 4e cubed. Okay, so let's use the standard formula, which is y, take away the y value, which is 1 over 4e squared, equals our gradient, which is minus 1 over 4e cubed, lots of x, minus the x value, which is e. So y equals minus x over 4e cubed plus e over 4e cubed plus 1 over 4e squared. So therefore y equals minus x over 4e cubed. This fraction here can be simplified to 1 over 4e squared, and 1 over 4e squared plus another 1 over 4e squared is 2 over 4e squared, which is 1 over 2e squared, and that is the same as, so here's my negative x minus x. Actually, it's probably easier if I just take the denominator of e to the 3 and make that e to the minus 3. So that's minus x e to the minus 3 over 4, which is minus 1/4 times by x e to the minus 3. And this is plus 1/2 e to the negative 2. And that is what we're aiming for. So yeah, so some fiddly bits at the end there by moving denominators sort of upstairs and dealing with fractions and whatnot, but there we go. So y is minus 1/4 x e to the minus 3rd plus 1/2 e to the negative 2 as requested.